So independent samples t-test. For this, we're going to be examining two groups that are distinct from each other. So we're going to do some coding of the data here, and then that will help the SPSS to identify which value belongs to which group. So let's say we are checking a test drug versus placebo. Maybe 0 is the placebo. But if there's anyone here that doesn't know what placebo means, you say. Okay. So let's say you are doing a clinical trial testing a new drug, and you want to see how effective it is at lowering blood pressure versus placebo. Placebo is just an empty drug that contains nothing. So you want to see if it is better or the same as a placebo, and you are checking the mean BPs for people. Okay, sorry. I do not read this up. This upper line. So we're basically checking for those who were treated with the drug, those who were not treated with the drug, whether there is a difference between their mean blood pressures. And for that, we're going to be using a similar, another data set. It's called free-term SBP_ditch. So let's go to SPSS and import that data set. So we go to File. Let me go to Open Data, SBP ditch, and then I'll share that screen because I know this may not be visible. Okay, so this is the SBP ditch data set, and then we're going to be doing independent sample t-test. So for independent samples, usually you have Comfort. You're saying something different. What is different about your about what you're seeing?
Okay, sir. I just when you moved your screen a little bit, I think your cursor was hiding some information. So now I can see it's looking the same. Thank you very much, sir.
All right. So we go to analyze, come to compare means, and then we come to independent samples t-test. So the test variable, what we are testing, what we want to check, the variable that we are testing to see if it is different across the two groups is systolic blood pressure. So we are trying to check if systolic blood pressure is different between those that were treated and those that were not treated. So there, for paired sample t-test, there's something called a grouping variable, which is usually a categorical variable. So this is treatments. We put it here, and then it's going to ask you to define the groups. So you define the groups as 0 and 1, and then you click on continue. Are we all there?
Sorry,
yes,
sir. What is TRT?
Treatment.
Okay.
TRT stands for treatment. So 0 is somebody that received no treatment. 1 is somebody that received the treatment. So I'll just go back a bit and we take a look at the data set. This is the treatment variable. So even though this variable was not designed as a categorical variable, what do you call it? This data set, I believe it was done. It was derived quite some time ago. So it's possible maybe at the time this was how the researchers wanted to do it. So, but then you can see that there are columns, there are cells where you have 0, and then there are cells where you have 1. So between the 0s and 1s, so for the treatment, some of them have 1, which means that they have been treated, and some of them have 0, which means that they have not been treated. So we can still treat it as a categorical variable. We go here into analyze, go to compare means. So apologies, everyone. If you could just give me a minute. I am on call here, and the on-call nurse is giving me a call. So I just want to see that it's not an emergency.
Please, I didn't get this Freetown whatever in my mail. Does anybody have it? This Freetown SBP data set.
Okay, so can you go to the email we got for the link to this class? Just above that table, there's a sentence there that indicates that there's a link. Did you get that email for today in stats 2 hours ago?
Yes, I got it.
Okay. So there's a table calendar. So once you click on the link,
yeah, thank you so much.
Hello. Sorry about that. Okay, so we're about to do the dependent sample test. So we come here to analyze, come to compare means, and come to independent sample t-test. So the variable that we're testing is systolic blood pressure, and the categorizing or the grouping variable is treatment. Then we define the groups. So we check, we enter 0 and 1, as we have already demonstrated in the data set, and then gives us this is all we need to do actually. But then we can also go into the options and see that this is 25%, and then we click on OK to display the output. So let me just share the output window. Okay, it's already been shared. Okay, so this is the output window, and then now that we are having 2 different samples, you can see that there is something here called the Levin's test. So one of the assumptions for so there are a number of conditions that you need to satisfy to be able to do a paired sample t-test. Number 1 has to be numerical data, that's continuous variable, both of them. Number 2, the variables need to be normally distributed. Number 3, the variances have to be equal. So there should be no significant difference between the variances across both samples. So if you look at it here, this is the Levin's test. And then it has two rows. We're interested in this row that says equal variances assumed. So if you look at this, the significance of the difference. So this is telling you this F statistic is basically the difference between the variances of treatment group 0 and treatment group 1. So the variance, the difference in the variance across these two groups is what this F statistic is estimating. And then this gives you the significance of that difference. So the long and short of it is that there is no statistically significant difference between those that the mean BP of those that received the treatment and those that did not receive the treatment. So we can go ahead and interpret the T test of this first row. So we can see this is the T statistic. This is the degree of freedom. Because we are having two samples, the degree of freedom is now n-2. And then this is the mean difference in the blood pressure of the two groups. So this is basically giving you that those who were treated have, on average, their systolic blood pressure was on average 37.8 or 37.9 millimeters of mercury lower than the BP of those who were not treated. You look at the p-value, you can see that it is statistically significant. If you come to the confidence interval, you can see that it does not cross 0, which means it is statistically significant. So the interpretation basically is what I've just said, is that on average, the blood pressure in the treatment group was 37.9 millimeters of mercury lower than that of the non-treatment group. Right. So on average, the systolic blood pressure of the treatment group was 37.9 millimeters of mercury lower than the non-treatment group. And for 95% of them, their systolic blood pressure was between 34.7 and 41.1 millimeters of mercury less than the non-treatment group. We go back to the presentation and we can see the output. So this is a class exercise. There's a data set called the ionchild.csv. This is
I have a question, please. I have a stop.
Yes. Okay.
The previous page, why did you say lower? I didn't see any sign that says lower. Could it be 34 points?
Okay, let's go. Let me go back to the. So you can see that we are using these two treatment groups, 0 and 1. We are subtracting group 0 from group 1. Sorry, we are subtracting group 1 from group 0. And group 0 is the people that did not receive treatment. Group 1 are those that received treatment. Okay? Are you that so far?
I'm with you, but if you continue, I'm with you.
All right. So group 0 is those that received no treatment. Group 1 are those that received treatment. So the comparison of the mean involves some subtraction, and the subtraction is we're subtracting this one from this one. I'm just giving a very simplified explanation. I'm sure you have seen how to calculate the t statistic in class. So basically, the subtraction is we're subtracting this treatment group, the average of the treatment group from the average of the no treatment group. So, and don't forget, what we're looking at here is blood pressure. So we're trying to see if this treatment works. That is why we are subtracting the average BP of those that were treated from the average BP of those that were not treated. When you come here, you can see the mean difference. So the mean difference on average, this is the difference in BP between group 1, group 0 and group 1. Group 0 is no treatment, group 1 is treatment. So on average, this is the difference, which means on average, the BP is 37.89 millimeters of mercury, less than in the treatment group, is less than that in the no treatment group. Are you with me so far?
I'm with you. I'm with you.
So that is the average difference between two groups. And because the p value is less than the set significance of 0.05, then this difference is statistically significant. But just reporting the p-value, I'm sure it has been mentioned in class, is not enough, because it doesn't really give us, it might not be very useful for us in when we're interpreting the data. So we come to the confidence interval. The average, yes, the mean value of BP reduction is 37.89. But then on average, 95% of the subjects would have had a reduction of between 34.7 and 41.1. Does that make sense now?
Thank you, Charles. Thank you.
All right. So let's go to the practice exercise. Import this data set into your SPSS ion trial. This is a trial that randomly assigned 1,500 pregnant women to daily iron supplementation or placebo. So to assess whether iron supplementation increases hemoglobin by the time of delivery. Only 982 women were identified at the time of delivery. So out of the 1,500 women that initially started, only 982 were identified at the time of delivery. Some of them had a spontaneous loss of pregnancy, or they did not come back to the hospital for delivery. So this data set, this ion trial data set, it's giving you the hemoglobin concentration at the time of delivery. So basically, we want you to estimate to compare the hemoglobin concentration at the time of delivery for those that received iron and those that did not receive iron. So I'm going to mute my mic now for a minute. So you can do the paired sample T test for this and use it to estimate whether or not there was a difference in hemoglobin concentration. So I will unmute 5 minutes, ask for answers. Okay, we should have been able to do the successfully able to compare the two groups by now. So does anybody want to share their screen and interpret the results? I'll take the first person to raise their hand. Or do you want me to choose randomly? I don't want to put anybody on the hot seat. Any volunteers? It doesn't matter. It doesn't matter if your results are wrong. Even in real life research, results you get mistakes all the time. Okay, somebody's raising their hand. Who's that?
Let me try.
Yes. All right. SMN, is it?
Yes, I need to share my
Okay.
screen.
Yes, go ahead. Let me stop my share.
What's happening? I'm trying to share, but it's saying post.
Okay, let me see.
Disabled.
Okay. All right, you can do that now. You can share now.
Okay. Is it this one? Let me see. I think so. Okay.
Would you like to show your work first of all, before the output?
Okay. Let me see. Where is that on? Yes. I think it's this one.
Okay.
So I imported the data set into SPSS, and I think if I remember the question correctly, it had to do with HB hemoglobin and then two groups, as in those that received the iron supplementation and those that did not. So looking at this data set we were given, 1 would represent the group that received the iron supplementation, while 0, you scroll down, there's some zeros in data set, would represent those that did not receive the iron supplementation. And let me go back up again. Oh. Okay, then this is the HB level of all the participants. So, like we learned, I went to analyze. Hello?
Yes, go ahead. Just do the test. I think we all know how it's done. So just
share the other screen.
No, do the analyze thing.
Okay, there's this toolbar that is blocking me. I'm coming. It's not allowing me show, as in I can see it, but it's blocking where I'll click on the analyze and everything.
Okay. So just show us your output window and explain the results to us.
Okay. Okay, this is my output window. This is the group that did not receive the iron supplements, and this is the other group that received the iron supplement. So they were 481 in number. Those who did not receive the iron supplements, they were 501 in number. So the mean hemoglobin level for those who did not receive the iron supplements was 10.84. while that of the group that received iron supplements was 11.71. Then, after doing the independent sample t-test, the test statistic, very strange, turned out to be negative minus 7.002, meaning that the difference between, sorry, not the difference, the mean difference between the group that received the iron supplements and the other group that did not, the mean difference in HB level was minus 7.002, meaning that the treated group had HB levels lower by this mean difference, sorry, minus, what is this, minus 0.8? Hello? Can you hear me?
Yes, we can hear
We
you.
can hear
Yes,
you.
yes, we can hear you. I'm just listening to
Okay,
your
sorry.
explanation. Yeah.
Okay, so let me summarize. I've said too many things. This is the untreated group. This is the treated group. This is the mean HB level in the untreated group. This is the mean HB level in the treated group. The mean difference in HB levels between this group is this, minus 0.87, while this is the t statistic. If we look at the two-sided p, it's less than 0.001. Then the less than 0.
Okay, so yes, so is it a significant difference or not?
It's a significant difference if we look at the two-sided p. Then if we look at the confidence interval.
Okay, I believe you are a bit confused, and I think others who are also on the call might be confused by the negative sign.
Yes, I am.
So just go back to the group statistics and actually, don't worry, just unshare your screen. Thank you very much for sharing. What you have done is correct. Is the interpretation that needs a bit of tweaking, and I'll demonstrate this in a second.
Okay.
So that comes here. So if you look at this, you see that you are given the last line says you are given data of hemoglobin concentration at the time of delivery and asked to compare the average hemoglobin in those who received iron versus placebo. So this time around, group 0 is the no, actually, you're right. Sorry. Group 0 is the people who did not who were the placebo group, and group 1 are those that received the supplement. Let me just go to the data set. So here it is. Let's just go ahead and analyze the independent sample t-tests. The test variable is the hemoglobin, and the treatment, this is the grouping variable. We define the groups, group 0 and 1. I'm just being a bit more fast because ANOVA might take us a bit of time as well. So this is the confidence interval, that's all fine. And then we click on OK. So let me just add the output window to my share. screen. Okay, so here we have the placebo group. Here is the treatment group. So the reason why you are having negative signs is because those that were treated with iron ended up having higher higher amount of hemoglobin at the end of the pregnancy.
Sorry, is
Okay,
it higher? Sorry, is it higher or lower?
higher. So if you subtract 5 from 3, you are going to get -2, right?
Yes.
So that's essentially what is happening here. We're subtracting the treatment group. We gave them hemoglobin, and at the end of the pregnancy, they have a higher hemoglobin than those who received placebo, which contains 0 iron. So by the time you subtract the average hemoglobin of those people who were treated with iron from the hemoglobin of average of those who were not treated with iron, that's the reason why you are having negative T statistics and negative mean difference and that. So on average, those who were treated with hemoglobin had 0.8 gram per, their hemoglobin was 0.8 gram per DL, higher than those who were not treated. And the 95% of them had an increase of between -1.1 and an increase of between 1.1 and 0.6. Somebody has their hands up. So one has to be careful interpreting these data, and sometimes we use value labels. For example, if the categorical variable was actually given value labels, it will be displaying here as placebo and treatment rather than 0 and 1. So that's something to consider when you are creating your own variables. Comfort, do you understand my explanation now? You are asking about why the increase is negative.
Yeah, I don't understand that too. Why the increase is negative?
Okay, the reason why the increase is, yes, the reason why it is negative is because we used the treatment group as group 1, which was subtracted from group 0. So group 1 has a higher average than group 0. If you look at the mean here, the mean hemoglobin for those who were treated is 11.7. And the mean for those who were not treated is 10.8. So if you subtract 11.7 from 10.8, it gives you a negative value. So at the end of the day, those who were treated with those who were treated with hemoglobin had on average 0.87. Their hemoglobin was on average 0.87 gram per DL, higher than those who were not treated. So mind you, this is independent sample, so we are not looking at before and after. This is not before and after data. This is data at the end of the study, and we are comparing it between 2 groups. So we are just saying that the group 1 is greater than group 0 by this value, and 95% of those of the group 1 subjects have values between this -1.1 between 1.1 and 0.6 greater than group 0. I don't know if that makes sense.
Yes, it does. Fine.
Okay. All right. So we